to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but want to be its friend.
Yes, that's what we are. Hi, I'm one of your hosts, Dr. Moiya McTier. I'm an astrophysicist, a folklorist, and a friend to the universe. And my bestie is...
Connie, and I'm a curious person and a aspiring friend to the universe as I learn from Dr. Moiya.
But you and the universe go way back. You have a different relationship with it than I do, but one that's like your own and special.
Yes, you're right. You're so right.
Mm-hmm. Well, how close are you feeling to the universe this week?
I'm feeling distant from the universe. I need to go outside. I probably said that last week, but it's still true. Working on it. So I need to get outside and just like I need to open up my Skyview app and look at the stars in Orlando because I live in a state where I can see stars now, and that's really delightful. And so I can open up Skyview and see the stars. So I need to do some of that today or this week.
Yay. Awesome. Yeah, that'd be really nice.
How close are you feeling, Moiya?
I am feeling still emotionally close to the universe like I was last week, but intellectually a little bit more distant than I would like to feel. So I realized it's been a while since I've read an astro paper. So I think I might want to get back into that groove. And Bestie, how would you feel sometime about maybe an episode where like I share my screen and we go through a paper or two together?
Okay. I can
show you how to read a scientific paper.
Yeah, because I've done some of it in my journalism career, but I could always learn some more because I skimmed a lot, and I know that's probably the thing. Like it's okay.
That's the thing.
Okay, you go to the abstract and you go to the conclusion, and we'll go over that, and that will be great because we want to check our sources, folks. We want to make sure that when we're reading things online and we have a little inkling that it might not be true, let's go look at it. So I think that would be a great idea because I need a refresher.
Awesome. Yeah. Okay. So future episode in the works.
Yeah.
Friends.
Yes.
Awesome.
Let us know if you're into that.
But this week, we are here to talk about the things in space that we're grateful for, to go along with the week. I hope you all are getting ready to, have some yummy food and spend some time with loved ones and reflect on things that you're grateful for. But for this week, here are some of the space-themed gratitude items on our list.
Yes.
Yeah, Connie and I each wrote some down, and I think we're going to alternate going back and forth.
Okay.
To decide who goes first, I don't know, I was going to do maybe something about, like, which of us has, like, the most Thanksgiving holiday traditions.
I don't really have any for Thanksgiving. Yeah. It kind of bounces around.
Oh, okay.
Yeah. So I don't have one of those.
Nice. Great. Yeah, I always spend Thanksgiving with the same group of friends, and then we watch the same movie every year. And to be fair, I don't always stay for the movie. But I think last year I skipped, so this year I'll stay and I'll watch Mitchell, and it'll be a fun time with my friends.
Nice.
Yeah.
I love that.
Okay, so I guess I have the most tradition, so I will go first.
Go first.
And I'll say, this is so nerdy.
Your whole list is, you're an astrophysicist, so your whole list is so nerdy, and mine is so, it's pretty. So just get ready for that, listeners, because that's the dynamic here. Get ready.
That's truly our dynamic, yes. And I'm grateful for you, Bestie, that you just let me be my weird little nerdy self.
Oh, absolutely.
Who gets excited about the Higgs boson. I'm so grateful for the Higgs boson. And then I guess kind of going along with that, gravity. Just do you know about the Higgs boson, Bestie?
So I've heard of it, but I can't remember what it is. So you have to remind me.
It is, within the standard model of particle physics, a fundamental particle that, when it interacts with other particles, gives them mass.
Okay.
Mm-hmm. What questions immediately come to mind? Or should I just keep talking?
What else is a particle?
Okay, fantastic.
Yeah. Okay, because I thought it was a device or like a observatory or something that like a science named physical thing and not a particle. So tell me more there.
Oh, okay. Yeah, well, it was discovered at one of those big...
Okay.
particle observatory things, the Large Hadron Collider.
That one.
Yes.
Yeah. Okay. I've heard of that.
Yes. And the whole goal of the Large Hadron Collider is to smash particles together at high speeds to break them apart into even smaller and cooler particles.
Okay.
So there are so many different types of particles. Many of them are combinations of other things, but the Higgs boson is one of relatively few, I think maybe like 16 or so, fundamental particles that cannot be broken down into smaller parts. A fundamental particle is something like an electron.
Okay. Yes.
An electron isn't made up of anything else.
Okay. Because I was gonna say, like, where does it hit in the atom to electron size differential? But then also, then you can't break it down any further.
Right.
And that is okay.
Exactly. So an electron is a fundamental particle.
Yeah.
A proton is not. A proton is made up of other tinier particles called quarks.
Okay.
And it's a combination of, so there are 6 different types of quarks. Up, down, strange, charm, top, and bottom. I don't know why. I'll let you absorb that for a second.
And which one are you? Strange.
You know I'm strange. You know I'm strange quark. And Bestie, you're charm quark.
Yeah. Oh, thank you. I love that. Yeah. That one was my favorite one, obviously.
So the proton is made up of 2 up quarks and 1 down quark.
I'm imagining like gaming. Like I'm just holding a controller. It's like, okay, up, down, left, right. Yes. Charm is like a special button.
So there are 6 buttons on the game controller, and if you want to do the proton action, you have to do the combo up, down.
Okay.
If you want to do the neutron action, which is the other type of particle that exists within the nucleus of an atom, protons and neutrons, the neutron is down, up.
Down,
yes.
up.
That is actually so good for us because the down quarks are ever so slightly heavier than the up quarks, which means the neutrons, having 2 down and 1 up, are ever so slightly heavier than protons, which means neutrons will decay into other things. And protons won't. But we need neutrons to decay into other things through different processes for life to exist. So I'm really glad that the Higgs interacts with the quarks in such a way that the down quark is heavier than the up quark, because the down quark interacts with the Higgs boson more strongly than other lighter particles. And that's how the mass of the particles is determined. It's how strongly does this particle interact with the Higgs boson particle. And so a really heavy particle interacts with it a lot.
Okay.
And then we have gravity.
Gravity. Very important. I love gravity.
Yeah.
Sometimes, anyway.
Sometimes. You're right. Sometimes I cuss gravity out a lot.
Yeah.
But you don't always love things that are necessary for you.
Yeah.
And without gravity, we wouldn't have the other things on the list that I'm really grateful for. So, but like our universe wouldn't work the same without gravity.
Absolutely. I also love the Sarah Bareilles song.
Oh, what? Gravity?
Yeah. There's a Sarah Bareilles song called Gravity that I like.
Oh. Oh, nice. What are you grateful for, Bestie?
I am grateful for the moon. She's pretty.
Yeah.
I was like, I could leave it there.
And she knows it.
And she's a little elusive about it. Obviously, we talked about the moon a few episodes ago, so you can hear more about why I'm grateful there. But it's just really nice. It's nice to look out and see a bright spot of light in the dark of night. I love that she reflects the sun. Like there's still a connection between the sun. I love that she's tidally locked to our planet and helps our tides. Thank you for the lesson, Moiya. And I love the inspiration. Like I think I'll talk more about this later, but I really love the inspiration that the moon has given to people, to artists, to storytellers. Everything that has lunar or Luna, like it all comes from the like old storytellers, and that's really cool. So That's what I'm grateful for the moon.
Okay. My second one is the moment of recombination.
Okay.
This happened about 300 to 400,000 years after the Big Bang. And this is the moment that we get atoms with electrons on them for the first time. So early on in the universe, it was just soup. It was just a soup of particles just moving around together. All the quarks and the electrons and the Higgs bosons and all the other stuff just swirling. And as the universe expanded rapidly, it cooled down, so things had less energy and they were able to combine without just bouncing off of each other. So the first things to combine were the quarks, and they made the protons and the neutrons. And then the protons and neutrons came together and formed nuclei of atoms that were neutral.
When a proton and a neutron really love each other.
Yes. Well, when the night cools down and the proton and the neutron really love each other, they'll form a nucleus, and they'll look for a third. But it's still too hot out. The thirds, all those unicorns, they're still bumping into each other.
Mm-hmm. Yeah, they can't find their couple.
And it takes until 380,000 years after the Big Bang for the electron thirds out there to want to settle down and find the nuclei and then add their negative charge and create the neutral atoms.
Wow. Okay. Yeah. There's a chart, I assume. There's
Did
like a
putting it in
timeline.
throuple analogy help?
I think so. But also, I'm trying to. There must be a chart somewhere that you can send me that's like the order of the ages, where it's like on like Earth, we have like the different ages of like, the Stone Age and the Ice Age and all that. But like for space, it sounds like there are different like sections of that too.
Yes.
That I didn't quite realize. Like obviously there's the Big Bang and then there's like the moments where things have evolved over time. But a chart could be like a little timeline could be useful, if not shrunken very tiny for the amount of time it has to scale.
Yeah, a long time ago, Corinne and I did an episode all about the first 3 minutes of the Big Bang. Entire books have been written about the first 3 minutes.
Wow.
Yeah.
Wow. But minutes in like our current time?
Correct. Wow. Correct. In the first 3 Earth minutes as we define it. Yeah.
Wow.
The universe did so much. Different types of energy became dominant over others. It expanded to something like 10 to the 20th power times its original size. It got all of the first particles combined. Yeah, those.
Wow. Okay, that's a lot.
Yeah, recombination. And the reason I am so grateful for that moment, and yeah, we could totally do like a timeline episode for you, is that without recombination, the universe would be dark, like completely. If the electrons had continued to swirl around through the universe, bumping into each other, they would have continued to block the photons, which are fundamental particles of light, and they wouldn't be able to reach us. So we actually can't see before that moment. We call it the dark ages of the universe because the photons are all trapped. But after recombination, the photons were free. And that's why we can see distant galaxies and stuff.
And anything in our faces, right? Like photons go directly in our eyes. So we can see?
That's true. Yeah. If the electrons were truly just like swirling around, we also wouldn't be here to observe anything.
Right.
But yeah.
Also, if we could without it, for some reason, the photons in the eyes, like just the little, like everything else wouldn't happen. So then we wouldn't be here. But if everything else was the same, but photons only affected your eyes. Something like that. Yeah.
Yeah, that's my thing. What's your next thing, Bestie?
My next thing is that I'm grateful for Venus because she's really pretty, which is just, my answer. But every time I'm on Instagram and I see NASA or someone post the pictures of Venus that they've presented, it's just like a glorious burning gold, like orange, yellow, burnt ball. And it looks very cool. And, Venus is love, and it's our neighbor planet.
Our twisted sister planet.
Yeah, we can see her in the sky sometimes. That's really nice. Like a bigger star, but you're like, something weird about that star. It's really bright. Oh, it's a planet.
Yeah, Venus is so bright. It was once a wandering star.
Oh.
It looks like it.
Yeah, it does, because it reminds me of the sun, like the pictures of the sun with the molting lava of cosmic sun stuff. So that's why I love Venus.
It's beautiful, but deadly with its, 900-degree surface and sulfuric acid rays, like stuff.
Yeah.
I don't know, sulfur dioxide clouds. It's really not safe there.
No,
but I think that captures Venus's vibe well.
Yeah.
Actually.
Yeah, for sure.
It's an appropriate association.
For sure.
Even though it was named Venus long before we knew anything about the surface temperatures.
That's always really cool. It's like, but it's like how Jupiter, well, I won't get ahead, but like how, I don't know if you'll mention this, but how Jupiter is stormy, and it's like the god of thunder.
Yeah.
I love that connection.
That's true. Yeah, it's amazing how it kind of worked out that way.
What's your next one?
I'm grateful for Earth's atmosphere.
Okay. Yeah.
Yeah.
Tell me more.
Well, it lets us breathe.
Great. Love that.
It traps heat in these days too well. But that's our fault. Like, we're doing that, not the system. And it blocks 75% of ultraviolet radiation from the sun.
That's very helpful.
95% of the most harmful ultraviolet radiation that the sun emits.
That's nice.
It prevents the smaller space debris from really hitting us because it will burn up in the atmosphere.
Wow.
And it's the reason stars twinkle. Stars twinkle because their beams of light are so narrow that it's called aberration. It gets aberrated or just like wobbled as it passes through especially the water vapor and stuff in our atmosphere, which is why we put telescopes so high on mountains so we can be above most of the atmosphere and there's less twinklage. This is also how you can tell the difference.
Is twinklage a word?
It's a Moiya word.
Oh, then I'm co-signing the word, so we can make it happen. I love it. Twinklage.
Twinklage. And it's how you can tell the difference between a star and a planet. The planets do not twinkle because they're closer to us, and even though they look to be about the same size sometimes, their beams of light are actually much broader and stronger than the star's beams of light by the time they reach us. So it doesn't get jostled by the atmosphere. I.e. no twinklage.
No twinklage. Venus doesn't twinkle. But if you see another star that looks really big and bright and it's twinkling, it's a star.
And then it's probably Sirius.
Ah, yes. The brightest star in our sky. Has that changed? Was that a thing that changed at some point?
The North Star changes.
Really? What do you mean by that?
Yes, because the Earth's rotation, its axis of rotation, points to a specific spot in the sky. And it just so happens that right now there is a star there called Polaris. And so we call it the North Star.
Yeah, that's what it was, the other word in my head.
But the Earth's rotation doesn't always stay pointing in that direction. It wobbles a little bit. We call this precession, and it's predictable. It happens in a circle, and it's the classic comparison is like a top spinning.
Yeah.
And how it like wobbles as it spins. And so Polaris is currently our North Star, but the precession will turn our axis so that we point to the star Vega next.
Okay.
And 5,000 years ago, it was a different star.
Yeah.
I think the cycle is 26,000 years.
Oh, okay. Okay, sure.
Yeah.
Oh, maybe that's where I got that from. Well, that leads well into my next thing, which is I'm grateful for stars. They're pretty. They twinkle. Love that part. I love how much they twinkle. And I love the connection to like storytelling and like ancient worlds and stuff, just because like we have constellations. Obviously, it ties us very closely to like Greek mythology and like this, Kratos, Western civilization or whatever. But I've also been asking Moiya about other cultures and how they have thought about space and stars, because I think it's cool to see how they saw the same things and what stories they told, because it seems like there's been a consistency in telling stories about the stars. Like, I'm sure there are some places that don't have like constellation type stories, but it's like really nice to think about people looking up at the sky and thinking of stories and seeing images and just like a connection to creativity, a connection to imagination, because we start looking at these stars and we're like, I do not see that. And then you start to kind of understand how things still just overall looked different when you look at like ancient art and ancient works. And so like you maybe start to make the connection of like, okay, I guess that is a ram. I guess that is Taurus. Like that's the bull up there. So I just really love that there's a connection to storytelling and that we've held that connection for, at least since the ancient times for a particular part of the world, obviously.
Yeah.
And that's really cool. So I love that.
It is. I love that. I know why you picked Taurus. But I also love that you picked Taurus because it is one of the oldest constellations that we know of.
Really?
That still exists.
Huh.
Yeah. The Taurus constellation, the bull constellation, goes back not just to the Greeks with their association with Zeus. I think it had a stop in Egypt, but it goes back to Mesopotamia. It goes back to the great bull of heaven that was mentioned in the Epic of Gilgamesh. So the Taurus constellation is, like 4,000 years old, 5,000 years old.
Wow. Oh.
At least.
Huh. That's very cool.
Is that your favorite constellation?
No, I don't know that I have one. It's mostly just that I see Orion the most, and it's the most identifiable to me. So, but that's why I need to get outside and stargaze some more, so I can identify some other ones in my area.
Yeah, that'd be nice. My next one is that I'm grateful for Earth's magnetic field.
Yeah, I love that.
Our magnetic field protects us from the sun's solar wind. There's this constant stream of charged particles being just blown away off the surface of the sun. And it is what stripped away Mars's atmosphere for the most part. And if Mars had stronger gravity and more like volcanic activity with outgassing to produce more of an atmosphere, it probably could have held on to something, but it doesn't. It's a little bit less massive than us. So Earth's gravity helped us hold on to an atmosphere, but also our magnetic field, which Mars doesn't have much of, or as much of. Our magnetic field kind of just redirects the charged particles of the solar wind around us, and that's awesome. But we do catch some of the particles from the solar wind, and they get dragged up to the north and south magnetic poles, and then we get aurora. So it protects us and gives us a beautiful light show at the same time.
Ooh, I love that. I'm surprised that Aurora didn't make it to my list, but sometimes I forget things are space. And also I haven't seen any, so I'm just jealous.
Me too. That's on our bucket list. We'll
okay.
see some aurora sometime.
Okay, great. Yay.
The magnetic field also protects us from cosmic radiation.
Thank you.
Yes, thank you. There are these really high energy cosmic rays that come from energetic events like gamma ray bursts and supernovae and things exploding and merging and all the fun stuff that happens out there. But these charged particles, when you are outside of our atmosphere, astronauts have higher exposure to this cosmic radiation, and we've measured it. And it's like being in an X-ray machine a lot more than you're supposed to without the lead vest.
Yeah. Yikes.
Yes. Yikes. So our magnetic field protects us from those, which is fantastic.
Yay.
Thank you, magnetic field.
My next thing I'm thankful for is Pluto. Just a tiny planet, okay? Just a tiny planet. It's a different kind of planet. But it's a planet. She's a planet. Anyway, I love Pluto. I think partially because, if you think of how we learn about the planets and it being the ninth one and kind of like the last one, it's the runt of the litter, it's the underdog, it's the youngest child, it's the baby, and then they demoted it, and then that made us all really attached to Pluto. And then it has a heart shape on it. Moiya, what's the heart shape thing that I see in photos of Pluto?
I don't know exactly what caused it. What is it called? Sputnik planitia. No, that is a space in the western lobe of the heart.
Oh, okay.
It seems like
the
yes, the heart has lobes. We've studied them and we've named parts of them, but it seems like it's an impact feature.
Okay.
Of being struck by something.
Wow. That's great. I also love Pluto because I love Sailor Pluto from Sailor Moon. She was in charge of time.
Interesting. Not Sailor Saturn.
No, Sailor Saturn was of death and rebirth. They kind of flipped.
They swapped them.
Yeah, not sure why. So Sailor Pluto was the guardian of time, basically. They're doors to time, and the Sailor Scouts have to go to the future, and they meet Sailor Pluto. And Sailor Pluto is like a lone warrior standing over the gates of time for some reason. But then she appears in the normal world with the girls, and she's an older student, like a fashion student in college. I don't actually know what she did because I think I've read fan fiction that has had different jobs for her. So I don't remember what she does, but she's older and more mature and just really elegant and stately and cool. And she's cool.
She's cool.
She has a giant staff that has a red ball and a heart on it, which then I don't know. I don't remember when we learned that there was a heart on Pluto, or a heart shape on Pluto. 2015. So it predates Pluto being announced as having a heart. So it's just really cool because it's she's the one lone one. And then Pluto's all the way at the end. But then Pluto gets demoted and then she kind of comes in and out of the core team. And so it just it ties up really nicely.
Oh, okay, nice. Good reasons.
Yeah.
Hi friends, it's me. I'm testing out different stuffing recipes and Connie is trying all the variations to see which one I should make for the big day. So I figured I would share some messages with you. The first message is a clarification or an addition of information, an appendix, if you will, about the heart on Pluto. I checked and the heart is actually called the Tombaugh Regio after Clyde Tombaugh, who discovered Pluto in the 1930s. And the Sputnik planitia is a basin within the entire Tombaugh Regio. It's an icy basin in one of the lobes, and that planitia plus the Regio in total were indeed, we think, caused by an impact of some sort on Pluto's surface. Okay. Now that that's done, I can thank all of my patrons. Thank you all so much. I'm an independent podcast. This show doesn't have any big companies backing it and funding it, so it would be really hard to make this show without your support, and I appreciate it so much. I want to shout out my Sun-like stars, Scott Reynolds, Tom T., Nicole Bartlett, Ashley Shambo, Mark Mahoney, and Bruce Sedloff. What an amazing group of people. I'm so happy to see this club growing. Thank you all so much. And I want to welcome our new pre-main sequence stars, Shanna Mendel and Kelsey. Thank you for joining. I am so excited to see the deuterium that you fuse in your cores. If you have not joined our Patreon, but you still want to support an indie podcast and hear your name on the show and make it to the patron star chart and get research notes for pretty much every episode, you can do that for $5 a month at patreon.com/palebluepod. We also offer annual memberships, and from now until the end of November, you can get 30% off annual memberships for an extended Black Friday shopping experience. But instead of, consumerism, you're supporting an independent podcast. How great would that be? And that also goes for all of the Multitude shows. We are all doing 30% 20% off our annual memberships on our Patreon. So head on over to patreon.com/palebluepod and sign up for an annual membership. If a monthly or annual donation or membership is not up your alley, that's fine. You could become a supernova in the Pale Blue Pod sky at the PayPal link in the episode description and make a one-time donation. And of course, if you can't support the show financially, we understand. You are still space and we still love you very much. The best way to help Pale Blue Pod grow is actually to get more people listening to the show. If we improve our download numbers, then we can make more in ad sales, for example. So if you take an episode like this one and you send it to others, say send it to all of the people that you're going to be having Thanksgiving with, then you're making more people friends of the universe, and we can all be happier when that's the case. All right. Thank you so much. Connie has tested out the different stuffings and has narrowed it down to 3 favorites. So we're going to have to keep testing after we finish recording. But let's get back to this conversation about what we're grateful for in space. Bestie, I'm so grateful for the conservation of angular momentum.
Okay, I understood like 2/3 of that. I know what all the words mean, but I don't know what they mean together. So I added that, or rounded that up to about 2/3.
Got it. The conservation of angular momentum is the same physics law that figure skaters use when they swirl faster when they bring their arms in. It's the idea that momentum, the energy that you have when you're moving, basically, it's not like scientifically accurate, but like basically the energy and force that you have with you when you're moving, if you turn or if you hit something, that energy or force, it still needs to be conserved. It can't just disappear. It has to be transferred to something, or it has to shift in some way. And this is basically what's responsible for everything in space swirling and orbiting around things.
Okay.
Without the conservation of angular momentum, things could just fall straight towards each other through gravity.
Yeah.
But instead, you have to swirl around. So you end up with disks of material that we call accretion disks around black holes that can't just fall straight in, but have to slowly conserve and siphon off their energy by swirling closer and closer to the black hole. And that's how we can see that black holes are there. Without the accretion disk and all of the material in it swirling together and heating up due to friction and then producing these big ultraviolet or X-ray light shows, we wouldn't be able to see where black holes are. Without the conservation of angular momentum, the solar system wouldn't all be orbiting. The rocks that combine to make our planets wouldn't have all been swirling around together and having an avalanche effect that would make our planets. I guess gravity could still have formed things in other ways, but it's the motion of stuff is important to me because I love planets and I love orbital dynamics, but also that means that there are rocks out there that are just orbiting around in our solar system, occasionally impacting us. Because all of the rocks were orbiting on their own momentum paths that usually were in the same direction, but not always.
Yeah.
We had an impact with a thing called Theia that produced our moon. We had impacts with asteroids that likely deposited the ice and the hydrogen and the building blocks for water that made it so that our planet is now something like 75% water at the surface. There are a lot of necessary steps for life and for that life to be interesting that depend on the conservation of angular momentum.
Yeah. Is this part, the swirling stuff, is that part of why the moon and the earth are locked the way that they are? Just like that natural swirl around vibe? Or maybe a little bit, but not a major part?
They're locked because of gravity.
Okay.
But they will continue to move because they have momentum that's conserved.
Yeah, because that sounds like what you said, which was once you get onto like a ramp basically, and you're able to like start turning, like the momentum keeps you going. It came up recently for some reason. It could have been the moon episode, but it could have been like a movie I watched. Can't remember at this point.
Got it. Okay.
Yeah.
But yeah, it's the rule of just keep spinning.
Yeah. Just keep spinning, just keep spinning. My last thing is I'm grateful for the Earth. We've talked a lot about the things up in the sky, what we can see from Earth, but I'm grateful for the Earth. We live on it, and she's pretty. She's really got a lot of dynamism and like variation in color and obviously like texture structure that you can see from space, which is cool. I don't know that any of the other planets really look like the Earth does in terms of like the different, like there's land, and so that's the like brown, and then the blue from the water and stuff. And so that's all very cool. Actually, side question. When we are viewing Earth from space, does the atmosphere of any planet, I guess, color how it looks? And then when you're closer, it looks different. And so then does the Earth look different inside versus outside?
That's a great question. Mm-hmm. Yes.
Okay.
It looks a little bit different.
Okay.
But our atmosphere isn't strongly colored in the optical.
Right.
And it's not very hazy on average, but it will look a little bit different because the light from the sun does, like scatter through. When you are doing an observation from Earth, you have to calculate something called the air mass, which is how much atmosphere are you looking through. If you're looking straight up, you're looking through less atmosphere than if you're looking towards the horizon, because you're going through just like a longer...
Yeah.
Does that make sense?
Focal length, kind of. Yeah.
There's trig there.
That might not be the right word, but yeah.
There you go. Okay. If you are looking through more atmosphere, things will look different. So if you're outside the atmosphere, you're not going to have that same type of effect, but you might have something like, depending on where the satellite is, if it's like on the other side of the Earth from the sun, like if the Earth is between the satellite and the sun, then sunlight might come around and get focused through the atmosphere towards it. So it will be slightly different, but not very.
Okay.
Not like if you were a Venusian, I think.
Yeah. Okay. Cool.
Yeah.
Interesting. Yeah. And like many of the reasons that you've mentioned about Earth, the atmosphere, the magnetic field, are what keep us alive and not frying and cooking from the sun. So really like that part. And it's home. It's where we live, where all my family and friends live. And I wish we were doing a better job to keep it safe and healthy. Yeah. And I wish we didn't, the people who want to be better to the Earth, I wish we could do a better job of it in our desire. But, sometimes it's really hard to do that.
Yeah. I take great pleasure in thinking about how much stronger the Earth is than us.
Yeah.
I am quite comforted by the fact that the Earth is going to be here no matter what.
Yeah. And she will be fine.
Yeah. We might change it so that we can't live here anymore, but she will be fine. Yeah.
Is the Earth often personified feminine? Or is there a consistency that you've noticed?
Oh.
I feel like I've asked you, I don't remember if it was on the pod or real life, but the sun and the moon kind of have, the sun is often, would you say masculine? The moon's sometimes feminine?
I'd say it's more split.
Split, okay. So I was just curious if you had thought about the Earth, because obviously in Greek mythology, Gaia is mother. We do say Mother Earth a lot. Curiously enough, on Sailor Moon, the guardian of Earth was the main male character, the male damsel in distress, as probably a last minute we could give him something too.
Right.
So I was just curious if you had an idea of how we've in mythology and story we've personified the Earth one way or another.
I think that it's more varied.
Okay. It's interesting.
I was running through my list, and I think it's not quite as common for the Earth to be represented by a single personified deity who is the Earth. Like Gaia is the Earth in Greek mythology. In Norse mythology, Odin crafts Midgard out of the body of a giant named Ymir. So it was a male person, but it's not like still a living male creature.
Yeah.
And I think in Nahua or Aztec lore, the Earth itself is like nestled within the body of a crocodile.
Right.
Or
There's
alligator.
animalistic connections.
But the caretakers, it is, I think, more common for the Earth not to be a personified thing, but to have caretakers. And those, there are many genders, but there's often like the kind of classic icons of Mother Earth. You see that as in a lot of pagan beliefs, but there's also like the green man and the idea of like the stag with his big horns being like the spirit of the forest.
Yeah.
But that's like forest specifically, not necessarily the whole Earth.
Right.
So
right.
yeah, it's just like a lot messier. Yeah.
And then the Earth has been broken up in a lot of things. Yeah. Like into realms, Poseidon versus Zeus in the sky and stuff like that. Interesting. Yeah. Love that stuff. Thanks.
But even then, like Gaia was the earth, Pontus was the sea, Oranos was the sky. And in Greek mythology, these different regions are all personified beings.
Yeah, yeah.
That's less the case in other religions that I know of.
Yeah, yeah. Gotcha.
Yeah.
Cool.
Let's see. I am grateful for the cosmological principle.
Okay.
Yes.
Sure.
The cosmological principle is this, I think maybe maxim is the right word. It's like a heuristic. It's a rule of thumb that we have.
Okay.
Kind of like basic set of truths about the universe. And that is that on large enough scales, the universe is homogeneous and isotropic.
Okay.
Meaning homogeneous, it's the same everywhere. And isotropic means it's the same in every direction, which is important because this is a reminder that we're not the center. It might look like we are the center, but that is because the universe is isotropic. It looks the same in every direction. However, we have to remember it's homogeneous. So it would look the same in every direction no matter where we were in the system.
You mean like us, the planet and the people of Earth?
The universe.
Okay, the universe would look the same anywhere else.
From no matter where we were looking from, if we're looking out at the universe, it will always look like we're in the center because it looks the same in every direction. And when you're at the center of a sphere or whatever, when you're at the center of any shape, it does look the same.
Gotcha.
In all the directions.
Yeah.
But because we know that the universe is also homogeneous, we could be in any place in the system and it would look the same.
Gotcha. Okay. Last episode, you said that they kind of figured that the universe looks like a rugby ball. Was that what it was?
The galaxy looks like a rugby ball.
The galaxy looks like a rugby ball. Okay. Because then I was imagining the inside, like just like space inside of a rugby ball, and how if you're a point in that space, in that three-dimensional space, and you look around, it would just be that same brown, like whatever the inside of a rugby ball would look like. But even then, it's like you can kind of see distance, but not, it's still the same. So it was really helping me understand it, because like if you're on like this end, it's like you can see that there's like maybe a shorter distance here and a longer distance there, but like it's still the inside of the rugby brown ball, and it's still the same air inside. Does that? Your face is not encouraging.
I don't know what you're trying to say.
It's fine.
Okay.
Because I kind of don't either, but I think I get it. But I don't know how to explain it back to you in my rugby ball terms, so we can forget it.
Okay. But the cosmological principle works on scales larger than the galaxy, so larger than this rugby ball shaped thing. It is only on larger scales of the universe, but also not too large, because the large, like the ultimate structure of the universe is on these like big filaments, so clearly not homogeneous, but it is filaments everywhere. So I guess, kind of. But in this part of the universe that we're in, when we're doing our observations, we can assume that it's going to be the same everywhere. So let's not assume we have some like preferential perspective.
Right. Yeah, we used to think the Earth was the center of the galaxy.
Yes, we did. Yes, we did. I didn't say this in our last episode about Gaia and its map, but the first map of the galaxy that a scientist person tried to make was in 1785, I think, when William and Caroline Herschel made a map by looking out and seeing where... like how many stars can you count in different directions, but they made all sorts of terrible assumptions, like all of the stars are the same brightness, and it was just it was bad, and so it ended up with this ridiculous map. But they were also like kind of assuming, I think, that we were near the center at first anyway.
Right.
Yeah.
No, it's like we got to figure out, like, are we on the left side? Are we on I want to know, like, where are we? West side universers? West side. Obviously, west and east is not like the proper terminology at all.
The Milky Way is, we can approximate it as roughly a flat disk, and it's, symmetric around that disk. And the solar system is about halfway between the center and the edge of the disk. And it is just outside one of the main spiral arms.
See, we're not even in the core.
And we don't want to be.
Oh.
We do not want to be in a spiral arm. That's where there are a lot of stars with a high likelihood of some sort of supernova explosion or other catastrophic event that could endanger our atmosphere and our habitability.
Yeah, no, okay. Yeah, we don't want that.
Yeah, we want to be outside. And we are at a special type of orbit that will always stay just a little bit outside of the spiral arm. We're not going to pass in and out of it like we would if we were on a slightly different orbit. Because the spiral arms aren't rigid structures. They're like traffic jams of stars. You can pass in and out of them if you are moving on a particular orbit, if you're moving in a particular way. But our car is just like chilling behind the traffic jam, just like constantly staying behind it, not trying to pass it.
There's so many levels of movement when you think about space, and that is one of the things I think gets me overwhelmed, because thinking about the universe swirling, and we're on this tail end, but like not in the center of the tail.
The galaxy, babe.
Yes, the galaxy. And so we're not in the center of the tail there, but then there's just like more swirling, but then there are individual galaxies in there shifting and moving.
No, because we're still in the galaxy.
Okay, yes, we are in the Milky Way. Well, obviously, but I'm saying the Milky Way is the spiral, but then the universe is bigger.
Bigger.
Which, like, I know, but sometimes they flip back and forth in my head while you're talking.
No, I get it, because I think that's probably how I am when I talk to biologists, because I can never remember, like, is a cell or a virus or, like, a whatever bigger. Like, I can never remember that, so I understand.
Yeah. Okay, but I think it still goes to the point of, like, yes, the words get me confused, but then also just thinking about how many things are moving at the same time, but then all in a direction, but then they're doing their little directions, and then the planet is also spinning, and then in a circle around a thing that's also moving in a thing that's moving in a bigger thing that's moving in a bigger thing, and then there's other stuff, and it's a traffic jam. That's just like an interesting new way of thinking about it. So thank you.
What is a traffic jam?
No. I said it is a traffic jam, so that helps me think about.
But Connie, what is a traffic jam?
You're asking me if I've actually understood, and
yes,
I'm gonna say the stars in the arm of the galaxy. The spiral arms?
Yes, I'll accept that. Yes.
Okay.
Yes, the spiral arms that we see are not like tubes that have specific stars stuffed into them and they're all moving as a rigid structure. It is a traffic jam that things can like move in and out of, and the traffic jam moves over time as things move in and out of it. Yeah. I had to take a whole class on fluid dynamics to understand this. So
Okay, great. Yeah.
yeah.
All right. There's a little more wrinkling happening.
Good. We got twinklage and wrinklage in one
Twinklage
episode.
and wrinklage. Yeah.
Awesome. Yeah. Do you have any other things you're grateful for?
You. I'm thankful for my bestie Moiya because we met when we were both going through hard times and like needing companionship, and you've been a great friend and I've loved learning from you and now working with you, and you're a delight, and I'm glad you're my bestie.
You're going to make me cry on mic. Stop it.
My bad.
Thank you. I love you too.
Love you too.
Damn it.
My bad. It's a holiday episode, so
You had to get me in the feels.
Yeah, it's that time of year. I'm sorry.
Oh, I appreciate it. I appreciate you. Thank you for your friendship and for being here, and for many, many years to come of being dear sisters.
Yes.
Yes. And silver sisters.
And silver sisters.
Okay, now you've made me cry, so I have to be silly.
Okay.
This is the Cosmic Thanksgiving episode. What dishes do you think would be served out in the universe for Cosmic Thanksgiving? I do have some thoughts.
Okay, please start.
Yeah. I think that there would be some garlic mashed molecular clouds served with a dark matter gravy.
Ah.
I think that there would probably be some, I'm going to say like, brown dwarf casserole. So definitely some brown dwarf casserole.
Okay.
And some baked magnetars and cheese.
Magnetars?
Magnetars are a special type of pulsar, and a pulsar is a dead core of a star that has gone through all of its fusion in its core. And a magnetar is a pulsar that has a really, really strong magnetic field.
It sounds like a Pokemon name, to be honest.
You know what? You're so right. And actually, yeah, because there's neutron stars, pulsars, and magnetars, and they like I can absolutely see that being an evolution track. Connie, what are your favorite Thanksgiving foods? Maybe we should do that. You tell me your favorite Thanksgiving foods. I will translate it into Cosmic Thanksgiving.
Yeah, because I was thinking about asteroid stuffing. The way that my grandma and family usually make stuffing is like the cornbread stuffing, and like it's got the like crispy pieces, and that's like the asteroid belt. But some of my favorite Thanksgiving foods are mac and cheese and yams, especially when they touch. So if there's anything that's like two different things and then they just like slightly touch and like make something beautiful, that would be that would be a lovely cosmic space dish.
Ooh, what would the candied yams be in space? I think it would be
Go for it.
I think we're going candied hot Jupiters. For candied yams.
You keep teasing me with these hot Jupiters, and we have to get to it at some point.
Okay. Maybe we can do an episode on like the different types of planets.
Okay. Because I didn't know there were different types besides planet and dwarf planet.
Yeah, like rocky, gaseous.
Oh, yes. Yes. I did know that. Gas giants. We love a gas giant.
Yes, we do.
Those are like the two things that I'm like, this is Thanksgiving. Other stuffing I do also really like. I can do turkey. I know a lot of people don't like turkey. I can do turkey, but a lot of my family like to do chicken instead. And so, chicken stuffing, gravy. But I think the other dishes kind of go in and out. Green beans, maybe collard greens. it kind of shifts around.
Yeah, I don't know what the turkey equivalent is. I think they might all be vegan out there, but
Probably.
they're gonna take whatever it is. It's probably gonna be like, I'm making the executive decision that it's antimatter deep fried in supernova oil.
Yeah. Yeah. Absolutely.
No fire hazards because they're already out in space.
Yeah. Lots of
Actually,
cooking.
here's a little lore drop. Every time you see a quasar, that's actually just the universe deep frying some antimatter.
And just like little popcorn pieces, like deep fried quark Oreos. Oreo, that's your next
Quark Oreos.
That's your next special Oreo type is quark.
Wait. But you can have the proton Oreo quark, which is the regular style, 2 cookies and the cream, and then you can have the neutron style quark Oreo, which is like the cookie in between 2 slabs of the filling.
And you have to like eat it really daintily in order to get it without the what is it? Which one is it? Is the cream the proton or what?
No, the cream then is the down quark.
Okay. Just enjoy my down quarks. That would be delightful.
Well, on that note, I think we have sufficiently
so sweet potato pie. Do you have a sweet potato pie in space option? Bake it in the oven until it's brown.
I think I'm trying to do something with pie and like circles and nothing better than something Einstein ring something is coming to mind.
Yeah. Okay.
Yeah.
That's fair.
Okay.
We tried. I had to get my last
I tried.
dish in there.
This is why I am not an improv science comedian. Awesome. Any final thoughts on Cosmic Thanksgiving, Connie?
No, this has been a lovely Thanksgiving. Thank you for having me for Cosmic Thanksgiving. It's probably would be my favorite Thanksgiving. I would like some quark Oreos.
Some quark Oreos. Yeah, absolutely.
Dear friends, remember that no matter where you are or what you are thankful for, you are space.
Yeah.
Okay, great.
Bye.
Bye. Pale Blue Pod is hosted by Dr. Moiya McTier and Connie Gibbs. Moiya created the show with the funny and talented Karine Caputo with help from the Multitude Productions team.
Our theme music is by Evan Johnston, our cover art by Shay McMullen, and our audio editing is handled by the superlative Nisha Stanton.
Stay in touch with us and the universe by following @PaleBluePod on Instagram or check out our website, palebluepod.com.
I, Moiya, am Go Astro Mo on all socials.
And I'm @ConStar24 on Instagram.
If you want to support our show, join our community at patreon.com/palebluepod or send this episode to your family and friends group chats.
We're a member of Multitude, an independent podcast collective and production studio. If you like Pale Blue Pod, you will love the other shows that live on our website at multitude.productions.
Thanks for listening to Pale Blue Pod. We'll be back next week.